Welcome again to Let's Talk Advanced Chemistry, Chemistry 2 with Pastor Dan. We're looking today at bonding. Beginning the process of bonding. Bonding is defined as chemical bonds, which are the process of two or more elements coming together, combining two or more elements chemically. Now, there's two types of bonding that exist, ionic and covalent. All right, we're going to define each of those for you. Covalent bonding, the second one we're going to do is bonding due to shared electron pairs, and we'll talk about that next. We're going to look at ionic today. Ionic bonding is bonding due to charge caused by electron transfer. We do something called electron dot. If you go back and look at the Chem 1 notes for bonding, Lewis dot is in there. There's a lot of practice in there. Means you're representing ionic bonding, so the way that we show it. So I'm going to show you a couple examples, and then we're going to go from there. So here we have sodium chlorine. First thing you need to do is determine how many valence electrons sodium has. The periodic chart, right over here. Periodic chart, we see that sodium has one valence electron, so we put 1 dot right there. And then chlorine has 7. It's over here on the side, 7. So we put 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. There's 7 valence electrons. Now, these aren't the most stable states. They're most stable states when they get to the same as the noble gas configuration. So for sodium, it will be neon, same as neon. For chlorine, it will be argon. It'll be the same. Sorry about the fumbling with this one. Going back here to neon, I believe it is. So, no, not neon. Off the hook. And then for chlorine, I think krypton. Nope. All right, let's take
It's argon.
So sodium, if I lose that 1 electron, brackets, and it's charged positive. Chlorine, we're going to gain 1.
Okay, again, that's because
I had 11, now I have 10.
I have 11 here. If I lose 1, I have 10. That's why it's positive. Chlorine, I had 17. If I gain 1, it's 18. That's why it's going to be
electrons. I had 17, now I have 18 electrons, so its charge is negative. Now those charges are equal in magnitude but opposite in charge, so plus 1 minus 1 equals 0. So we get NaCl is ionic bond. All right, we've got 3 I want you to do. Try and pause these, work them through. All right, okay. So here are the answers. There we go. We got aluminum 3 valence electrons, fluorine 7. So we lose 3, it's 3 plus 7, gain 1, so I have 8. I need 3 times that to get them equal. So it's AlF3, Mg and N, so it ends up with Mg3N2, and potassium and phosphorus K3P. Alrighty. Now, one other thing we'll look at is something called lattice energy. I'm going to show this to you. I'm not going to spend a whole lot of time actually going through, because I'll be honest with you, the entire time in the college we never actually did the process, but I wanted to show the process so that way you can understand what you're looking at. This is the energy to form an ionic structure. That's what lattice energy is. And when we do that, we convert crystals into vapors of each ion, so the charged particles in a gas form. So here would be an example of the ionization lattice energy for sodium chloride. First thing we do, take the formal charge, enthalpy formation of sodium, we flip it around, and so instead of being negative on the chart, it's 419. Then for that same chart, we can see the energy needed to vaporize it, go from a solid to a gas, and that is a positive 107.7 kilojoules per mole. That is also from the enthalpy formation. Now this one here, we're going to lose 1 electron. That is the ionization energy, amount of energy you need to lose 1 electron. So it's 496 kilojoules per mole. Then we have to vaporize chlorine. That's enthalpy formation problem. Then we have the electron amount of energy needed to gain 1 electron. So it's a negative. So we add those together, the total valence, the lattice energy is 787 kilojoules per mole. Now I'm gonna have you, if you want to practice this, but those won't be on any additional practice beyond this next one. just to see the process, how it works through. Now, the only thing that we will need to know is the structures of lattice, and these are basically cubic structures. They're three-dimensional squares, and they're basic central cubic structures. The simplest is called the simple cube, and it's just 4 electrons, so 1, 2, 3, 4, 5, 6, 7, 8, 1/8 of a total atom inside of there. And then in this one here, the body center, we have the other element in the center there. So that's going to be a body center, actually end up with 2. And then 1, 2, 3, 4, 5, 6, so that's 3. So we end up with 4 total atoms inside of those. Those are the 3 basic structures that exist. They are simple cubic, body-centered, or face-centered cubics for lattice structures. All right, now that's it for lattice structure. That's it for ionic structures. We're going to do quite a bit more with covalent bonding. All right, we're done. No problem. Take care. God bless. Bye.